everyone, this is the first lesson of Chapter 9, Graphing Quadratic Functions. In this lesson, you will analyze the characteristic of graph of quadratic functions, and eventually you will graph quadratic functions. This lesson contains lots of important concepts of quadratic functions, so brace yourself. In mathematics, the simplest function of a family of functions is called parent functions. For example, general form of quadratic function is y is equal to ax squared plus bx plus c. This can be written in the simplest function as y is equal to x squared. These quadratic functions have shape of parabola, which if it opens upward like a U shape, this will contain a minimum like right here. And if it opens downward, backward of U shape, now you're going to have a maximum point around this point right here. You can also determine the shape by finding the value of A. If A was positive, then you will have upward shape where you will have a minimum point. If your A was negative, then you will have a downward parabola where you can find the maximum point. We'll look into more details in example 4. First of all, let's begin by graph a parabola. Use a table of values to graph y is equal to x squared minus x minus 2. State the domain and range. What we're going to do is we're going to use those order pairs and connect them with a smooth curve. The first one is at negative 2, 4, so which is at negative 2, 4 right here, negative 1, 0, 0, negative 2, and 1, negative 2, 2, 0, and 3, positive 4. Remember, parabola has a shape of U or backward of U. In this case, it looks like a U shape where if I just connect them, make sure that it's like a curve, not a straight line. So if I do my best, here's a curve. In order to state the domain and range, the domains are all possible x values that you could plug it in. In this case, there is no limit on the x where you can plug any number. You can go to negative million up to positive million. So in this case, the domain will be all real numbers. Sometimes I'll be using a symbol looking like one straight line with an R. This also means all real numbers. When it comes to range, the ranges are for the y values. Quadratic functions, you have to be careful because even though the domain could be any real numbers, the range has always a limitation. So the range looks like it has to be anything above this point, where yet we are not sure what this exact point is. However, I can assume the y has to be always bigger or equal to, I would say that's about negative 2 let's say 2 or 3 in between those numbers. It should be very small because it's not even half. This will be my set of the y values. Another word, I can have any y values that's going to be above this point, but it will never come back down. Here's another example. Use a table of values to graph y is equal to x squared plus 2x plus 3. Since this is quadratic functions, you should be able to eliminate all the linear functions. When I have negative 3, I should have 6, which is going to be about here. So that one works. When I have negative 3, 1, 2, 3, 4, 5, 6 right here, which this one does not contain. And let me just double check with other ones. It looks like in negative 3, definitely B doesn't have a point. For the D, negative 3, I do have a point, but it's above where the graph is drawn. So that's how I know A has to be my answer. So far, it's similar to what you've done in linear functions. However, when it comes to parabola, they do have certain facts that you have to know. The parabolas have a geometric property called symmetry. So when you have a parabola shape, that is, the figure is folded in half. So if you cut this in half, you will notice that there will be exact same on the left and right. And this should be the same when you have a downward. So if I draw the line, I know it's a little bit different, but you get the idea that my left side has to be same as the right side. These lines have a name. It's called axis of symmetry, where this axis of symmetry will also tell you whether you will have a minimum point or maximum point. These are also called a vertex. This will be very common for you to see on the problem, where they're going to ask you to find either vertex or axis of symmetry. Something that you have to be careful, when I'm asking you to find axis of symmetry, these lines are a vertical line. When I'm asking, I should have x is equal to what this number is. In order to find it, here is a formula that you can use. If you have y is equal to ax squared plus bx plus c, where a is not equal to 0, if you use x is equal to negative b over 2a, this will give you the axis of symmetry. Sometimes you can find it by just looking at the graph, but this will be very handy if you don't have a graph on the paper. Example number 2. Now you're going to use a lot of characteristics from quadratic functions. Find the vertex, the equation of the axis symmetry, and y-intercept of the graph. First of all, we're going to find the vertex. Remember, the vertex is the same as when I'm asking you to find minimum or maximum. Since this is upward graph where you cannot really see when they're ending, it's a lot easier if you find the minimum. The minimum of this graph is right here, where I'm asking you what is the coordinate of this point. So in this case, I have 2, the y value is at negative 2. So this is going to be your answer. For the second part, they're asking you to find the axis of symmetry. So by looking at the graph, you can find there is an axis of symmetry on this line. So I'm asking you, what is the x value of this point? So in this case, if you want to find the axis of symmetry, my x is equal to, that is at 2, and this is going to be your second part of the answer. The last one, in order to find the y-intercept, this is same as when you were dealing with linear functions. So the y-intercept is looking at the y-axis. When is this graph intersecting? It looks like it's at this point where my y value is at 2, so I can write it as 0, positive 2, and this is going to be my third answer. And in order to get the full credit, you have to write all 3 answers. Let's try one more time without having the steps written for you. This is the exact same question. First, we're going to find the vertex. Remember, the vertex is on the graph of either minimum or maximum. In this case, since it's downward, I can find the maximum, which is going to be, this is at 2, positive 4. Where the next one, if I want to find the axis of symmetry, I don't know if you have noticed, the axis of symmetry has to be where the vertex is at. Remember, your vertex was x equal to 2. So I know axis of symmetry also has to be x is equal to 2. The last one, in order to find the y-intercept, you're just looking at the y-axis, and the y-intercept looks like it's at negative 4. So I'm going to write 0, negative 4 is going to be my y-intercept. And that's how you answer the question. Example number 3, I'm asking you the exact same thing, except I don't give you a graph. In order to find the vertex, we're going to do it backward. We're going to find axis of symmetry first. Earlier, we were talking about that axis of symmetry can be found using x is equal to negative b over 2a, where the a and b are coming from the formula ax squared plus bx plus c. So let me take step by step. In this case, the a is equal to negative 2 because that's the coefficient of x squared, and the b is equal to negative 8. And keep in mind, you have to carry the negative sign as always. And for the last one, which we can actually find right away, the y-intercept has to be the c value, which is in this case negative 2. So let me plug it in. The x is equal to negative, b was negative 8 over 2 is coming from the formula where a is another negative 2. So let me put the parentheses. If I simplify this, well, let me do step by step. This becomes negative 8 over negative 4, which I will get, this is positive 2. So I have x is equal to, I have negative up here, negative 2 is my answer. So this was the axis of symmetry. Since you know the axis of symmetry, we are going to find the vertex by using the x coordinate. So if I know the x was equal to negative 2, in order to find the y, let me substitute these numbers into your equations so that way I can find the y value. So then y is equal to negative 2 times, if x was negative 2 squared will be, when I'm asking you negative 2 times negative 2, I get 4. Minus 8 times x is negative 2 again, and then at the end minus 2. If you simplify this, negative 2 times 4, negative 8, negative 2 times negative 2 becomes positive 16, and then minus 2. This will be equal to 6. Keep in mind, I'm not just asking you to find the y value, I ask you to find the vertex. So when you write the answer, I need to have a coordinate where x was negative 2, and now you know the y is positive 6. So far, I found the vertex, the axis of symmetry. Now, how do you find the y-intercept? y-intercept has always x is equal to 0. So if I plug 0 into all of the x's, this whole part will be gone and all you get is just negative 2. So the y-intercept becomes 0, my number is just negative 2, and that's going to be my third part of the answer. Here's part B. Let's try one more time. This time I have y is equal to 3x squared plus 6x minus 2. Again, if you don't have a graph, it's kind of difficult to find the vertex right away. So what I'm going to do is I'm going to find x's of symmetry, which will be using the form x is equal to, what was it? Negative b over 2a. In this case, a is positive 3. That's the coefficient of x squared. And b is 6 and c is negative 2, where if I substitute x is equal to negative b was 6 over 2 times a was 3, and if I simplify this, I will get negative 6 over 6, which will make x is equal to negative 1. This is one part of the answer. The second step was using this x's of symmetry, I'm going to find the vertex. Vertex also contains the x's of symmetry, where I just need to find the y value when x is equal to negative 1. So in this case, y is equal to 3 times x was negative 1, so negative 1 squared, plus 6 times negative 1 minus 2. If I simplify this, negative 1 squared will be positive 1, so 1 times 3, I get 3. And then 6 times negative 1 is negative 6. The last one, minus 2, this will become negative 5. And keep in mind, I'm not just finding y is equal to negative 5. I need to write a coordinate where x was negative 1, that's coming from here, and the y is negative 5. This is going to be your vertex. The last one is going to be simpler. When you are finding the y-intercept, this can be found from your c value right away. The reason is because, again, if you plug 0 into all these x's, you will just remain with the negative 2. So I know the y-intercept is negative 2, but if I want to write the coordinate, it's going to be 0, negative 2, and that's going to be my last part of the answer. In summary, the parent function of quadratic functions are y is equal to x squared. The standard form, this was the basic form where y is equal to ax squared plus bx plus c. This will be important for you to find which number represent a, b, or c. When you are graphing them, they will always form a parabola, either U-shape or opposite of U-shape. In order to find the x's of symmetry, if you have a graph, it will be easier for you to find because you just need to find when they are cutting in half. If you don't have it, then you might want to use the x is equal to negative b over 2a form. The y-intercept is still same. You're just going to find the c value, or from the graph, you can find it when they are intersecting with the y-axis. It's kind of hidden over here, but I'm assuming it's probably at this point. As I mentioned earlier, the quadratic functions will have either maximum or minimum depending on your a value. If a was positive number, the parabola opens upward and has a minimum value. On the other hand, if a was negative number, the parabola opens downward and has maximum value. The range of quadratic functions, if you had a minimum, it will be all real numbers greater than or equal to your minimum. If you had a maximum, the range of this function will be less than or equal to your maximum value. Let's look into an example. Consider f of x is equal to negative x squared minus 2x minus 2. Determine whether the function has maximum or the minimum value. In order to identify whether you have a max or minimum, we're going to look at the a value. In this case, a is the number in front of the x squared, where I only see negative, which means it's going to be negative 1. If a was negative value, then the parabola opens downward looking like this, which will form a maximum. So I know this function will have a maximum value. Continuing with the same function, state the maximum or minimum value of the function. So now that if you're actually looking for the value of the max, I'm asking you to find vertex. So repeating the similar steps, the first one was finding the x's of symmetry in here. The x was equal to negative b over 2a. Where in this case, the b is negative 2, a is negative 1. If I plug it in, negative times, you will have negative 2 for your b value, over, you have 2 times a is negative 1. And if I simplify this, you will get negative times negative 2 will be positive 2 over, you will have negative 2 on the bottom. this becomes -1. So I know x is equal to -1. And remember that we are going to plug that back into your function to find the y value. So where it says f of x, imagine that this is just y is equal to. So if I had that, y is equal to, you will have negative times x squared. If you had x was -1, -1 squared becomes +1 minus 2 times -1 minus 2. Then it becomes -1 plus 2 minus 2, which will become -1. So I know my y value of this vertex has to be -1, and that's going to be my answer. Part C, state the domain and range of this function. Since I know if I graph this function, it will have a maximum value where this point is at -1, -1. It's telling me first for the domain. Remember, you can plug any x values that you want, so it could be all real numbers. When it comes to the range has limitation because if this -1, -1 is my maximum, it cannot go any greater than -1. So I know the y has to be less than or equal to -1, and it could be any real numbers. In a summary, identifying characteristic of quadratic function from graph has different steps than when you graph a quadratic function. Instead of finding vertex first, in like example 2, you'll find the axis of symmetry using x is equal to -b over 2a. And using this information, you're going to find the vertex. And keep in mind, the vertex is same as when you're finding the maximum or the minimum. It cannot be both. It has to be one way or the other. Then you can find the y-intercept of using c value. Once you have the axis of symmetry with where the vertex is at, and if it was a minimum, which will form a U shape, I just need to find several more points. Normally, if you have at least 3 points containing one vertex and one from each side, you should be able to graph a quadratic function. However, what I suggest is find at least 5 points just to be more accurate. So if you have 2 points over here and 2 points over there, and they should be symmetric, and then you can form a graph. This will be a little bit better than when you have just a vertex with 2 points, and it could be either gets wider like this, or it could get narrower like this. You would not know with just 3 points. And keep in mind, it has to be a curve, not a straight line. We're going to practice how to graph a function of f of x is equal to -x squared plus 5x minus 2. First step is, again, you're going to find the axis of symmetry using x is equal to -b over 2a. In this case, if I was following ax squared plus bx plus c form, a is -1, b is 5, c is -2. When I plug it in, you will have negative, b was 5 over 2 times a was -1. And then it becomes -5 over -2, which becomes 5 over 2. Using x is equal to 5 over 2, we're going to find the vertex by plugging back in. It's going to be just slightly complicated since we're dealing with a fraction. So if f of x, the y, is equal to negative, x becomes 5 over 2 of this, you're going to square them, plus 5 times 5 over 2 minus 2. Simplifying this, you will have negative times 5 squared will be 25 over 2 squared will be 4 plus 5 times 5 is 25 over 2, and then you have -2. Since I'm dealing with a fraction, I want to have all the same denominator. If I want to do so, I'm going to make the common denominator as 4. If I had the first one, don't need to do anything, but the second one, since this bottom number is 2, I need to multiply by 2 to make it 4. Then it becomes positive 50, and then the next one, since it's over 1, if I want to make it to 4, I need to multiply by 4 on both sides. So -2 times 4, I will get -8. And this is all over 4. They are all having the same denominator. If I simplify one more time, this will become 25 minus 8. I will get positive 17 over 4. So I know my vertex. Here's the second part of the answer. You need to write a coordinate where x was 5 over 2, comma, y was 17 over 4. Then you're going to find the y-intercept, where y-intercept is written on your function as the c value. So y-intercept is at 0, comma, -2. I'm putting the 0 because we know that when you're finding the y-intercept, your x value is going to be always equal to 0. So that's how I know x is 0. Then step 4 is asking you to find a couple more points. So for example, if I knew the vertex is at 5/2, 17/4, I'd prefer to write it with a decimal so I know where exactly to plot it in. In this case, 5/2 is equivalent to 2.5. When you divide 17/4, I will get 4.25. We'll have at 2.5, I have 4.25, so 1, 2, 3, 4, about here. And then I remember our y-intercept is at 0, -2, so 0, -2 will be over here. So here's another part. If I knew the left side of my graph has to be exact same as the right side from the axis of symmetry, if the point was existing 2.5 to the left, then I also have to have one on the other side 2.5 to the right over here. So that will create your 3 points so that you can draw a curve. Otherwise, I'd like to find just one more. So let's say, what if I want to find what happens at 1? If I plug f of 1, then this becomes -1 squared plus 5 times 1 minus 2. If I simplify this, you will get -1 plus 5 minus 2, which is +2. So at 1, I will have a point at 2. For the same reason, since if there was an axis of symmetry, I noticed that I have to go 1.5 to the left, which means I have to go 1.5 to the right, and that will make a symmetric parabola. You can also double check. It looks like this point is at f of 4, so if you plug f of 4 and see if you can get also +2. That you can check on your own if you'd like. Now, all you have to do is you're going to make a smooth curve. So if I draw, it's a little difficult because I'm using a computer. That's my excuse. But this will be going like this way where you will have a parabola downward. This is how you graph. Real world example number 6. Ben shoots an arrow. The path of the arrow can be modeled by y is equal to -16x squared plus 100x plus 4, where y represents the height in feet of the arrow x seconds after it is shot into the air. Graph the height of the arrow. So simply they're asking you to graph. So we will be doing several steps. Make sure that you have enough space if you are writing this. The first one was let's find the axis of symmetry. X is equal to -b/2a. In here, if I plug it in, negative comes from your formula. B is 100 over 2 times -16 will become -32. If I simplify this, you will get 100 over 32, and it looks like I can divide by 4 on top and bottom. So if I do so, I'll get 25 over 32 divided by 4, I will get 8. For the real-world example, I prefer a fraction to be converted to the decimal. When you divide 25 over 8, you get 3.125. Using this, we will find the vertex. Since I know the x already, to find y is equal to -16. Instead of x, we're going to substitute 3.125. So then 3.125 squared plus 100, and x is again 3.125 plus 4. Using a calculator to make my life a little bit easier, 3.125 squared times -16 is equal to -156.25 plus, when you multiply 100 with 3.125, moving 2 decimals to the right, I will get 312.5 plus 4. Continuing to use a calculator, this is equal to 160.25, which means your vertex will be 3.125, 160.25. If you're using a fraction, that should be also equal to 25 over 8, 641 over 4. So when I graph, I should have at 3.125, I should have a little bit over 160. So around here, there should be a vertex. To find the y-intercept, this was the c value, which in this case was equal to 4. So then at 0, I should have 4. Knowing that this is axis of symmetry, when I go from here left 3.125, I should have a point at 4. So then if I add another 3.125, 3.125 times 2, I should get 6.25. At 6.25, I should have another point at 4. So then, since now I have 3 points, I could draw a curve looking like this, where this is going to be my graph. To give you a better idea of a graph, here is a graph where at 3,125, so a little bit above 3, there should be a vertex. This is at 3.125, 160.25 to be exact. And then at 0, 0,4 right here. And then remember, around 6.25, still have the 4. You could also plug in other numbers, such as you can plug in 2 to find out what should be this point. And then using the axis of symmetry, you can find out how far is this length away from the left, so that you can go exact same thing on the right side. Now that you have a graph, part B, using the same situation, it's asking you at what height was the arrow shot. And let's see, X was representing the seconds, where Y was representing feet. And then I could read it as at this point when you had the y-intercept 0,4, this is the beginning, because in real life you do not count any negative numbers. So from at 0 second before I begin anything, I was at 4 feet. The arrow was shoot when the time was equal to 0, or at the y-intercept, which is at 4 feet, is going to be my answer. Part C, what is the maximum height of this arrow? In order to do so, we're going to use the vertex, because the vertex is telling you either max or minimum. In this case, it was representing max since your A value was negative. My maximum height, so again, I'm going to look at the Y value, is over here when I had 3.125, 160.25. So I know that my maximum height is just a Y value, where the Y was 160.25, and remember the unit was feet, and this will be my final answer. This is the end of the lesson. Thanks for learning with me. Leave a comment if you have any questions.